So I think we'll just go ahead and just jump right into the next section. This section is your chance to ask any questions that you have about the construction, project development, installation process. This is kind of our project team that does the bulk of our Nebraska work. The one person we are missing is our technical project manager, who works really closely with the engineering team, who will work very closely with NPPD's engineering department to make sure that we've got all the pieces, parts, and things that we need in place. She headed back up after Fremont commissioning, and
she helps with all the paperwork for NPPD, like the forms.
Yeah, the K450 forms, and we'll go
some of that
into
stuff
some of that.
can seem fairly daunting, and so she helps through all that process.
Yep, and so Jeff is our program manager for Nebraska. He also does a lot of running around on jobs, making sure that product is getting delivered where it needs to be delivered, that the guys have everything they need. Jeremy oversees, he's also our president, which he always fails to mention, but he oversees all of our project teams throughout the region. And you know, we do a lot of work up in South Dakota as well. We're licensed in South Dakota, North Dakota, Wyoming, Montana, Nebraska, Minnesota. And we also do work down in the islands, down in the Bahamas and Turks and Caicos. So occasionally he gets to go spend some time in the sun, which I get very jealous about. And then I do, I'm the head of the solar department in essence, and I do a lot of the project development and making sure that all the financials are there and that projects make sense for communities as a whole. So I wanted to jump in by, we've been talking a lot about the monitoring system and just showing you what that system looks like. So this is actually what the front end of the system would be. So this would be the display that you would have up in City Hall, in the library, if you wanted to use it as a teaching tool in a school. And we will help you as the projects get developed, set up these systems in any way you want. You can also use it as an API and pull it into your homepage and your website to have as well. So it's a really neat, robust system. And we had one of their trainers come down to Fremont with us this week and go through a lot of the things that they could do from a software development side. So there are some custom things that if you want to do them as a municipality, you can. Like, for example, Fremont really wanted to have a coal equivalent on theirs because the whole premise behind their project is that they're trying to offset energy that they're producing from their coal plant by putting in solar energy. So that was something that was really important for them to show. So if there's, you know, a specific industry that you have in town that you're looking to offset, we can customize some of this how you want. We can customize the colors and the look and the feel to make sure you have your logos and it's all one big pretty marketing package for the public. And then we'll go into the back end. And this is the part that I really geek over because I like numbers and looking at data. So if we take a look at Central City, this is what you're going to see on the back end. It'll have a list of all the equipment that you have on your site, including your power logger is what actually just logs all the data, your cellular modems, all of your inverters, and then it'll show your weather stations as well. And what you see this red line is, that's what they call the blue sky equivalent. So if it was a beautiful, perfect day and the sun was shining all the time, how much should that system be producing based on exactly what modules you have on your system, exactly what inverters you have on the system, how many modules you have per string. Occasionally we will have varying string sizes on a project, or there'll be a different number of strings going into one inverter versus another.
Right, for example, these first two are showing 55.4 kW and the rest of them are 47.4-ish. These top two have a few more strings coming into them than the other ones. And so we can, depending on the size of the system, that'll vary a little bit. So there's not an alarming thing there that, hey, these are producing more than these are meant to. But we will get a notification if there is a problem with one.
And then the orange line is the irradiance meter, so that shows how much sunlight is in the air. And you can see, like, on this day, there were some clouds, maybe a little bit of rain in the afternoon, so that's why you're seeing the trackers are still going to track, the system is still going to be producing, but as those weather patterns come in, you can start to see the production go down on those. When we had our ice storm in December, basically everything was just flat for 5 days. And we thought something was throwing at first at Lexington, and, oh, go ahead.
I have a question for you when you mentioned the ice storm. Because you have control of the single access, is it a practice to tilt them with a storm approaching or not? I'm interested in what your...
As far as runoff goes, so that
So
it'll
it
run
wouldn't
off.
accumulate
The
on
still
the
positions.
panels themselves because they're
Yeah.
sitting...
That's not set into the system like that to do that. Now you could manually go out there and do that. It's not something that you see a lot, and so typically speaking, when we have seen that, even when we were working on some of these projects, and we would get an ice storm, most of the time, 90% of the time, by 10 o'clock the next morning, once the sun hits those black modules, it doesn't take long at all for it to come off, even if it's in a flat position.
Yeah, this was a very different circumstance, and just to get an idea of the severity of that storm, it took out, like, you couldn't see the camera lens because there was so much ice accumulation. It was about that thick on everything. So in order to get that off, you would have had to gone out with a pick and a scraper and
So as a
take that
follow-up
off.
to that, what if you have a major snowstorm and it drops 15 inches of snow? Now you got 15 inches of snow on the panel. The sun's not going to melt that off anytime
No,
soon. So I'm just curious.
You're in a waiting game at that point. There's really not a whole lot that can do.
or you crank them a little bit steeper. There is a snow stow position.
Okay.
So if a heavy storm is coming in, those
Yeah,
panels
you can
are going
hit
to
it.
stow at an angle to make sure that it runs off. But if for some reason there is really, really heavy accumulation and things are sticking, then I'd go out there and manually just crank some of those blocks and see if you can shake it off.
Yeah.
But that ice storm was just,
And they had, all the systems had tracked through the day, so they were building up ice while they were tracking the whole day long.
yeah, everything was covered.
From Scotts Bluff to
Yeah.
Central City.
Wasn't
Yep.
that ice storm like a snow-ice combination?
Yeah.
Yes.
Which was it down?
Yeah, I think your guys drove through it too.
Yeah, it
There were
was
some
not good.
systems down. It was a very extreme storm.
Yeah.
So we wouldn't expect to see something like that happen even once a year unless. But I was gonna go somewhere and I forgot where I was gonna go. But oh yeah, go ahead.
Do you have a graph that you can show us the difference of the two, what a day on the tracking system might look like compared to a day on the stationary?
I don't. Oh, well, I do have. Yeah, because I have Venango and Scottsbluff in here, so I can pull those up.
Well, one thing you'll notice is over the center of the day, you'll see the dip come here, and that's actually because the track, they're all but flat, and since the sun's farther to the south now, they're not getting as much as they can. So that's how come it comes up and then has a little hump in the middle.
Dip in the middle.
It comes back.
So this is the typical fixed tilt, and so you'll see the power curve on this for the blue sky is a little bit different. And one of the interesting things about Venango and Scottsbluff is those systems are angled slightly to the west, so they're not directly facing south. And that was because MPPD wanted to shave some of their afternoon peaks and to see how that production was different. So they were purposefully angled to the west for to hit those afternoon
I had
peaks.
so many farmers and ranchers stop me and saying, did you know this road doesn't run north and south right here? I can't tell you. I should have put a sign out there that says, yep, I know it's east-west.
They're trying to help.
Yes.
No, and they were nice about it, but it was pretty funny.
So those are neat, but you don't get the dip that you get on the trackers with this. You're just getting your kind of normal curve of
And you can
production
see
for the day.
how fast it kind of goes to a point when it's not tracked, where on the trackers, it really has a vertical curve throughout the morning and then flattens out for a long period of time before it goes down, where you don't get that with the fixed rig.
Yeah, and you'll see that there's kind of these funky little blips in the irradiance meter. There's quite a few power lines and poles and things around the Scottsbluff office because it's right in front of the office.
Yeah.
So occasionally you'll have a shadow that passes over that irradiance meter, and dips down slightly for a couple minutes before that shadow moves on. So those are all things that you have to take into account when you're looking at a site, that there are going to be some variations, especially if there are things that might throw shadows.
That's very true, and a good example of that is Aurora at the wastewater treatment facility. On the western side, or excuse me, on the eastern side, in the morning, there's trees right there that protect the wastewater treatment from the road. And so they wanted to keep those trees because it helps, you know, keep everything enclosed so it's not a visual eyesore. And but where we're putting that is, it is affected a little bit in the morning, and so you can see
Especially in
it.
the winter. The winter you
Especially in
get
the
worse
winter,
shadows.
because the sun's so much lower in the sky. But it's one of those things where we took that into consideration in the build design and actually, you know, accounted for that shading that we do get in the morning. So if you have some scenarios where, hey, the rays got to go right here, but there is going to be a little bit of shading, we can work around that.
Yeah, and you can see it in their power curve, because like Central City, today it was hugging almost perfectly that red line. Well, in Aurora, almost every morning it just cuts a little bit that way, because that's when we're getting the shading from those trees.
Yep.
But in the afternoon, we're getting a little bit of extra production over here, so it makes up for it somewhat.
That's a pretty common question that we get though is, hey, we want it to be right here, but we will have some shading issues. And, you know, with the cost of solar coming down, we can actually add more watts to the system to account for some of that and not make the numbers go out of whack. And now, 5-7 years ago, we had a few panels and it would have made, it would have really skewed the numbers, where it doesn't skew it so much anymore.
And on the back end of the system, we have varying levels of hierarchy that you can, add anyone you'd like as your municipality. So if you have, some of your city workers or public works department who really wants to drill down and be able to pull full data sets to track this, we can give them those permissions. If you just want someone to be able to go in there or get an alert when something really, really goes wrong, we can do that. So all of that stuff is pretty customizable, and we can set it up how you need to use it. But it's a great, robust system. They do also have a community solar module. We haven't had to use it yet, and I think just because the MPPD community solar structure is already there, we wouldn't necessarily need to use it for those community solar projects, but it is available.
You can tailor your alerts to a time period too, so you're not getting alerts at 2 o'clock in the morning. Molly will still get them, but
yeah,
you guys don't have to.
And so it's great. Like, Lexington is my first solar baby, and I still get all the alerts for Lexington, but we've had a couple of issues over there. Once we had a farmer run into the 34.5 line and take it out, and so about 5 a.m. we're all getting dings on our emails and trying to figure out what the heck is going on the system. And then they had a power outage where the ethanol plant took something out. And in both of those cases, we were able to get the system back online within, I want to say, about 3 hours.
Yeah, it did take.
They got the grid up and we got the system back online, so it doesn't take long. And when you have a community solar program where there's a third-party investor, any downtime is lost money for them. And so you can bet that they're calling us at 5 a.m. asking what's wrong with the system.
And in most scenarios, there's very few that would be an exception. It's all fully automatic. So when the power goes down because of whatever, whether there's a storm or a farmer hitting a pole, once that power is restored to the solar farm, it'll automatically, the inverters will see it. They go through their checks and balances that they have to go through. It's about a 5-minute period that they check and make sure all the lines and everything, frequency and everything's good. Once it sees that it is good for 5 straight minutes, then it'll automatically kick back on itself. On some of these bigger systems, we have to, because of the legalities with MPPD, we actually have to go out there and restart it ourselves. But for the most part, that'll all be automatic and you don't have to worry about it. If you're going on vacation and you're the head of the maintenance for that project, once the power is restored, it'll automatically come back on. You don't need to worry about it.
Yeah, Lexington, Jeremy has to lick his finger and stick it across a couple of diodes, and that flips the system back on, which
yeah,
is quite fun.
It's a crazy situation that they got there for sure. But all those high voltage things are that way. There's a little diode in there that if it's down for more than a day, you actually have to reset it, and the only way to do it is with a wet finger, it sounds crazy, but.
Any questions on the monitoring system or the back end? Okay. So let's jump into the project process. So what happens? City Council has approved everything. It's great. It's fabulous. What do you have to do next? The answer is mostly paperwork. Everybody wants to jump straight into the construction part because that's the fun part and you get to see something being built. But as you can see, construction's way down there and there's all this other stuff that has to happen first. We really, partner with the communities we're working with to make sure that this paperwork part is as easy on everyone as possible. So there'll generally be, and this is going to differ whether or not it's a community solar versus the buy-sell, but generally you'll have an EPC contract, which is the construction contract. If you have a typical city contract where, usually people are more than happy to work within that contract. There's also the K450. Now the K450 is the form that you need to fill out to get NPPD to start the system study for that project. Sometimes there's most of the equipment and interconnection equipment in place that you need, like a robust enough distribution line or a transformer that is the right size. Sometimes there is not. With the City of Aurora project, we did have to upgrade that transformer. They didn't have a big enough transformer on that site. So we had to work with NPPD to figure out exactly what size transformer we needed to put in that would be able to support that project. That process can take some time for them to go through their study, and we have our new project manager back there who's going to help facilitate all that as well. How long do you think we're going to see as a typical, for smaller projects, a typical process?
Pat, you probably have better.
The buy-sell is typically going to be the smaller installations.
Right.
And like you said, the distribution system's probably going to be pretty robust where those are going in. So it's going to be a much shorter time frame. The community solar, depending on the size and the type of studies that are involved, that could be a much longer process. If we have to start studying the transmission system and the impacts there, that can be a significant 6 to 12 month time frame versus several weeks of the buy-sell.
Yeah, and in working through the Lexington project, there was a couple of different kind of chunks on how we looked at that. So the first is, how is it going to impact the direct distribution system around that site? We placed Lexington right next to the Tyson plant because we knew the energy produced from that solar system would go directly up into the plant. And Joe was pretty funny on that because he gave it to NPPD, the 3 sites that he wanted to look at, and then he gave it to us. And he didn't tell either of us what the other party said the best site would be. And we actually ended up picking the same site. So it worked out well in that case. So there were no arguments over which site was going to be the best on that one. Then you also have to look at your substation and how that solar energy is going to affect the substation. And you kind of look at that in a worst case scenario process. So if that solar system was producing max capacity with absolutely 0 losses at how much those inverters can, put out, and all of that energy fed into the substation, what would happen? And in the case of Lexington, there were a couple times of year where that substation capacity dipped just low enough that the solar energy production would be more than that substation usage. And so we put in a grounding transformer to help mitigate some of that. It didn't happen, twice a year. It might happen, but that was just an extra layer of protection to make sure that if that substation is, or if the solar system is ever producing too much for that substation, then it'll curtail that production. So those are some of the things that we look at. And then for the very large systems, what NPPD has to know too is it ever going to go off their system onto Southwest Power Pool? Because if you get that big and stuff starts feeding back onto Southwest Power Pool, then you get into an entirely new level of studies and issues there. So we try and work with them pretty carefully to make sure that projects aren't bleeding into somebody else's territory on that.
And I'd just like to interject a point.
Sure.
You know, as I stated earlier this morning, if you're thinking about doing a project, and it sounds like most people in the room have some level of interest, you know, the sooner you get going, the better off. You know, it does take some time, and the larger projects will take a little bit more time. You know, and there's no standard rule of thumb on when you're going to need a transmission study or something like that, but we will need to do system impact studies to see what the impact is. That's what drove the Aurora decision. Yeah, we have to have a bigger transformer here because the impact study told us that. But if there is an interest, get us engaged early so we can start those processes.
And that's involved with your account manager.
That's correct. So I've just, if there's interest, get us engaged. The sooner we're engaged, we can speed that up as much as we can. It's all right.
Yeah, and a lot of times, like, if we're submitting a K450 for a municipality, like we just did this for Atkinson, we'll make sure the account manager has it and that NPPD gets it, so both teams are aware right away that something's going to be coming. The other part of the paperwork is the interconnection agreement, and that is going to be agreement between the city and NPPD. They do have a standard interconnection agreement that they developed as of about last year, I think.
Yeah.
That was put
Clip
into
and
place.
GenPro,
Yep.
we've got the standard agreement, so most of that stuff will be streamlined now because we've gone through that a
Yeah.
couple of times.
Once you get the initial one down, those tend to be pretty standardized. So after we start all the paperwork, we generally schedule a client kickoff meeting where you'll meet the team lead that's going to be on that, the technical project manager, and anyone else. Jeff usually attends for his clients. Doug would attend for his clients. And that's just important so we all get to know each other and we know how we're going to work through the process.
Setting expectations, I think, is a huge thing. You know, everybody can ask questions and we can try to set expectations so that they're not failed.
Yeah, and on our projects, we typically work pretty closely with the city teams,
Yep.
and we enjoy having the city teams involved because the more they learn and understand about a system, I think it's
Absolutely.
better for everyone.
Yeah, it's great. The electrical, head of electrical here in Central City, he was out every day asking questions and running around, and it was great because by the end of the project, he knew a lot about the system, and so we encourage that for sure.
And especially on systems that aren't the community solar that you're gonna own outright and do your own O&M on, the more you can be involved in the installation process, the better. So then we start the engineering phase. Geotech is a very important one, especially if you're doing a pile-driven system. That's where they go out and they do borings, I think, to 20-foot depth, just to see what kind of subsurface we have under there. Atkinson, we just did geotech on, and we have a very different site out there. It's a challenging site, but it's a great challenge. And we're actually going to be testing out some ground screw ATI tracker technology combinations on their site. It's going to be the first from TerraSmart and Array Technologies that we know of that has been done. And you know, those two companies are worldwide leaders in racking, so we're really excited to have that project get started and see what those technologies can do together.
That's where, when Jeremy was mentioning the different pile lengths at the different projects, that's where that's all determined from the get-go. That's one of the most important things to go.
And then the Alta surveys. The Alta survey, like, typically are used to determine land ownership and the borders of different properties. We also use them because you tend to find things like sewer lines that were supposed to be in one place and happen to be in another place. So
We didn't think so either.
So it's those are always are good for us to do, even though if we know that the city owns a big plot of land, we really want to make sure there's not anything hidden under there that might throw a wrench into our project plans. Structural for racking, Now, generally the manufacturers for those will do those, they know their product the best, so they'll do the racking structurals for us. They do everything to the correct wind loading and snow loading for this area. We know we're in a really windy part of the world, so they take all that into account when they're doing the structural engineering for that. The interconnection design within PPD, and I think Jeremy can kind of talk to this a little bit since you just had one of these meetings and kind of the process we have to go through for
Yep.
the buy-sell.
Yep, so we always like to meet with the owner of the site and NPPD on site so that we can look at all the available options. Because sometimes there's a clear-cut option on how we're going to interconnect, and sometimes it's not clear at all. And so we try to take the path of least resistance, which it affects, you know, it has the least amount of effects on the property. At Atkinson, you know, we have the option of trenching 750 feet and tearing up through their wastewater treatment facility, or there's a possibility of tying in a different spot. And so all those things can be determined during that interconnection design meeting with NPPD. And a lot of times, you know, 15 different options are thrown around, and through all the people there, we can come up with the best solution that makes sense for everybody. And so that meeting sometimes can be an hour and sometimes can be a day. But it's very important in the overall process that we have to go through.
And then last but not least is the electrical design. Now, going in, we have a typical, we have a design already in mind when we go into the engineering process. Like that we do on the very front site. Once we know a site, we generally know what the size is going to be. We know what product we're most likely going to use, and we know what that string sizing is going to look like. The electrical allows us to tie that interconnection design into the actual solar design into one nice pretty package. And we're gonna go through the Aurora design set to show you guys. There are some very specific things on the buy-sell projects that are required by NPPD, and I kind of want to walk through what each of those pieces and parts are, because they're different than other places, and some very specific pieces of equipment. Permitting is always dependent on who the AHJ is, and for a lot of these projects as a municipality, you're going to be your own authority having jurisdiction. So you may have a building department. Sometimes, you know, the city will just tell us to bypass a building permit. We usually go get one anyway. We want to make sure that even though it's your project, we're still properly permitting everything the way that it should be. If it's like your project, but it's on county line, there may be some other permitting requirements that we have. So we really make sure that all the permits are put into place. If it's a large project, you're gonna have to do a stormwater prevention plan as well if you don't have one for the property, you know, or we can do an amendment if you already have one for that property. And then state electrical permit is gonna be standard for everything. Our state electrical inspector will know about the project going in, and of course they come out throughout the project and at the end.
Yep, and I always have them out on the front side, give them a scope of the project so they know what to expect, and then they usually don't come back until the project's completed, and then we go through everything line by line, make sure that, you know, it's installed according to the plan set. If they have any questions, we answer it at that time. So.
Yeah, and everything that we install is to NEC 2017
Yep.
code as well, so you'll have all of your warning labels and all that fun stuff. Then the construction process and the commissioning process. The commissioning process is really our double checks to make sure that everything that was installed was done to the same specs as engineering, and making sure everything's working, because that's always important too.
Yeah, like all those red and black wires you see coming in that tray, every single one of them is individually tested to make sure that the integrity of the wire is still good after being pulled in, that the connection is good. We actually have an instrument that we can put on each wire that actually tells us if there's a nick in the wire. It tells us if the termination, where it's terminated, is good or not. And so we have very, very much confidence in the system when we go to turn it on that those systems are going to work. And so then after we do that, we actually go through each wire and individually test each wire for current and amperage flow on every wire as well. So the commissioning process is done as we go. And it's quite extensive. I mean, it takes some time to do that, just to make sure that everything's is doing what it's designed to do.
And if it's a system that you're gonna take O&M on a buy-sell rider, we recommend having your staff actually walk through the commissioning process with us, so they know what we're looking for and they know what we're checking,
sure.
and they have a true understanding of that as well.
We highly encourage, if you're gonna do your own O&M, you probably can't spend enough time with us while we're out there, because there's gonna be lots of questions, and the more they spend out there, the faster those questions are gonna be asked. And we've had several communities that they just love hanging out there, because it's fun and it's exciting, and they can learn a lot about the process as it's going too. So we'd highly encourage that.
So next we'll just dive into the construction process a little bit. Sometimes you can have a construction site that looks like this, and it's beautiful and sunny and nice weather. And sometimes you have days like this, which just happened to be this week in Fremont when we had a swamp out there.
And
So-
knee-high boots aren't high enough.
No. So you're gonna run into lots of different circumstances and things being thrown at you. Winter installations in Nebraska, we've done quite a few of. They're not our favorite, but we're still gonna have our guys out there. They're just gonna get a little messy sometimes.
Yeah, and one thing to note on this, and it's been a concern at all the sites, obviously, is, hey, this looks terrible. What are we gonna do to make sure that it looks good, right? I mean, that's a valid concern. And at GenPro, we do everything from the beginning. We do our own dirt work, we do our own concrete work if there's any involved, we do all our own bedding of sand, we do all that stuff. And so this is our responsibility. As soon as the ground dries up, we'll take our equipment back over there and we'll make it look pretty again. That's part of our contract. So you don't have to worry about a third-party company having to come in and making it look good. That's something that we do in-house as well. And that's one thing we really pride ourselves on, is making sure that you guys have one phone number to call if there's an issue. A lot of times you get 5, 6, 7, 8 subcontractors involved, and you don't know who to call to get an answer. And so that's one thing that we really feel like we have a lot of value, is that one phone call and you can get your answer.
So why don't you just walk them through?
Yeah, so this is the torque tube that you guys saw today that actually turns, and this is how they come. They come bundled together in those big rows, and we actually drive this big telehandler right down the rows, and we take them off with another piece of equipment and set them and put all the equipment, the shock absorbers, we put all the module clamps, we put everything on in the order that it goes, and then we set it on top of the pile, and we torque everything and torque mark it as we go. But the semi trucks will show up like this, and we have guys that are trained to run this equipment and take it off. And sometimes we're waiting on this equipment, and sometimes it gets delivered, ahead of time. On Fremont here, we had it plenty of time. But
sometimes the trucks will show up without telling anyone.
yeah,
It happens. So be patient with us if all of a sudden a giant truck is driving up to your site.
Michelle, who we were talking about earlier, our project manager, she's in charge of talking to the truck drivers, doing that communication, letting everybody know, hey, this is coming, make sure we have lifts on site to do it, make sure we're available. And she does a great job of coordinating all that stuff, and she'll keep you guys in the loop too on what's happening on all the time. This is what's going to be happening next. This is how we're going about it. And with that level of control, it really helps for sure.
And one of the points of this picture too is this is really large, heavy equipment. If you have storage on site or near the site, it's going to make life on the project a lot easier. We have our big warehouse, but if we're having to drive back a bunch of miles every day, it can get a little time consuming. So if there's storage on site,
yeah, so on that note, I'm glad you brought that up, because two things. This kind of stuff don't need to store inside. It's going to be outside, doesn't matter if it's outside. But we do need to have a place that's out of your way, so it's not in your way. But we do have some sensitive items that we would like to have inside if possible.
And locked up.
And locked up, like the inverters that are very expensive pieces of equipment. And, they're made to be outside, sure, but we don't want them sitting out in a mud puddle somewhere. They're a sensitive piece of equipment, so it would be great to have a place where we could store that. If not, it's not a problem. Like Gothenburg, they just didn't have any place for it. So I kept everything here, and then at the last day, I trucked it over there, and and we installed them the same day. So, you know, it's nice to have that on site. If you guys have that available, it certainly is helpful.
And it's gonna be very difficult for someone to walk off, like Gothenburg, there was no fencing or anything, but nobody's gonna be able to walk off with
Right.
something like that unless they have a bunch of equipment.
But yeah, you can see that there's a lot of steel on the ground. And the first step in the process is all those columns being driven into the ground. So we have a crew that just does this. There's 2 guys, depending on the site, could be six of our guys, but on a project that's the size of Central City, it'd be 2 guys. They come out, this takes them about a week, and they drive all these piles in the ground. They mow it first, and then they drive all the piles in the ground, and they are off to the next job.
I think that was Aurora.
Yep.
This is Aurora here.
You can see that line of
this is
trees
that
is what causes that shading
trees
in the
that I
morning.
was talking about.
But they
So-
also act as a block from the road to keep the dust from coming over into the solar site, so.
Now, one thing to note, we always like to have the site graded to about a 1% grade. It's not a deal breaker, but the end result is you got a lot nicer system that looks, I mean, not nicer, it looks a lot nicer when you're completed with it. You know, everything's square and even, and you don't see any humps and valleys into it. That's not always possible to do that, nor is it always cost effective to do that. But in Fremont and several of Gothenburg, several of the projects, it was fairly bumpy, and so they came in and flattened it out ahead of time for us, and it really makes for a nice install. On Aurora, they didn't want to damage this grass. Don't blame them. It's beautiful. It's like a golf course out there. And so you can see that some of the rows are a little bit higher than others. Once the panels are on, you really can't see it much. But if this is a big variation between it, you'd really see it. And if it gets too much, you know, you start getting shading from one row to the next. So we really like to have that graded down ahead of time if possible. Sometimes it's not needed. But this is the next step after we drive all the piles. Then we go through and we put all these big posts on. And it's usually about 6 guys that do this, and we can do a 500 kW block like you did Central City in about 4 days. We can do all of the clamps and get everything torqued, get all the bearings, get all the the fins in place for the drive lines, and get it all ready to go. We can do that in about 4 to 5 days. And then the modules take about the same amount of time. So you're looking at about 5 more days or so for a 500 kW block to put all the modules on.
And a lot of times we will hire local temp labor for the module hanging and mechanical hanging portion of that.
Yes, we utilize a lot of temp labor. We'll always have our main guys on site, our electrical guys and our guys that know what's going on, but just brute strength, you know, we need a lot of manpower to do this. They're about 40 pounds a piece, and by the end of the day, you can imagine you get pretty tired if you're hauling them by yourself. So, you know, like Fremont, I think we had about 10 temp laborers and 4 of our guys doing the module portion of it.
And one of the things we've started developing in the region, especially if we know in certain geographies we're going to have a lot of projects, is working with the local vocational schools to create training programs or summer internship programs. We're able to run those programs through the temp agencies as well, so we can go out to the VOTEX and have people learn about solar energy, and that, you know, that also creates a nice stable of local workforce for us.
Yeah, the temp agencies are great because they cover the insurance for those students and everything, so it works out really well. This is starting to build the inverter station. This is where the heartbeat of it all happens. This is my favorite part. So going through here was where we put all the inverters. We mount all the DC gutters on one side, all the AC gutters on another. We can build a station complete in about a day and a half for 2 guys. Depending on the size of your solar farm, will vary in how many inverter stations you have. We have 2 inverter stations at Central City. There's 6 inverter stations at Fremont. So Lexington has 14 inverter stations. So this is Aurora, and this is a very unique situation. So this is part of the buy-sell program that Molly was talking about. And NPPD has a specific way that they would like us to hook this up, and this kind of demonstrates how it is. You can't see the transformer, it's sitting right next to it here. but that transformer has two output feeds coming out of it. One output feed feeds the wastewater treatment facility, and then the other output comes into this first box, which is what they call a CT box, and it meters all of the flow of electricity through this box and records it here in the meter. We come out of the CT box and we feed, this box is called a disconnect SEL relay box that NPPD requires to put this in. And basically what it is, in short definition, is another layer of protection for them so that there's no backfeed on their line, is really what it is. Now, we built a disconnect into this SEL relay box, so there's a way to shut off the whole system right in this box. On the backside, do you have a picture of the backside? Probably not.
Yep.
Oh yeah, so, thank you. So that's the other side, and we have two inverter stations at Aurora, and one disconnect controls one inverter station, one disconnect controls the other, and this is the complete power setup for Aurora. This controls everything. So how that works as far as the flow is the flow comes through the solar panels, feeds through the inverters, back to these disconnects, through the SEL relay, back to the CT box, and back to the transformer. When it gets back to the transformer, they're metering that transformer 2 times. So they're metering it on the flow that's going out to the wastewater treatment facility, how much flow they're pulling from the grid. And then they're also managing how much power is being made by the solar system, and it's metered separately. So they know at any given time how much power has been pushed back to their transformer and how much is actually flowed to the wastewater treatment facility, and then they do the math in the middle. And so this type of setup would be very similar to any of that style of hookup that we would do. So this is what it looks like once we get all the rows tracking, and like I said out there, if you heard me in the field, I always like to have these poles towards the upper end of that, because the guy here at Aurora who mows this loves it. He can just get on his 0-turn radius mower and duck down a little bit and just shoot right under all those and make a really fast job of it. And if it's 5 or 6 inches shorter, it's almost impossible to do that.
Well, and a lot of times we will be building on floodplains, and they're usually just 100-year floodplains, but you know, anything along the river valley, almost everything is some type of floodplain. So by sitting those up just a little bit further, there's like a 1-foot clearance rule on those. We can keep it to those rules and just give us a little bit of extra height on those. So floodplains aren't totally, you know, out of the question or scary. We had a company that we work with quite often in Russell Pacific did a system that was 9.5 feet off the ground with these trackers because they had an even wider clearance that they needed to have on those. So it's possible. We're looking at well fields in certain instances as well, which are kind of a good double duty of some of that land. So don't be totally scared off if you have a plot of land that is a flood zone.
Do you have to go through some of the local rezoning and modifications of ordinances to allow for construction in those floodplains?
It depends on, again, if a lot of that is a local municipality controlled thing with the floodplain permits. And most of the municipalities throughout Nebraska don't have floodplain permits, so as the city, they're just saying, no, we're gonna allow this anyway.
Right, like Central City is a great example of that, right? I mean,
Central City is
partially in a
designated
floodplain.
floodplain.
Yep. And they have the jurisdiction.
Fremont floodplain designated? I can't remember.
If it was only the one for,
Yeah.
this was for sure.
How does ensuring that go with having it in the floodplain?
We haven't seen a difference in the insurance for those because it's a 100-year floodplain and not, you know, something more intense. We would not put it, I wouldn't put it in, what is the other, I can't remember which designation it is off the top of my head. I wouldn't put it in the more intensive
Extreme
floodplain designation.
The underwriters for the insurance now know that all the equipment's up off the ground, and that'll be one of the things that we report when they
Well, and people
quote the
build
insurance.
housing in these floodplain zones. They build everything in them, so I think it's kind of commonplace. There are, but speaking of zoning, there are some zoning regulations in terms of, you know, how land is zoned either by the city or the county. So Fremont, on their newest project, had to redesignate their own zoning for their projects for it to be either commercial or ag. Like usually commercial and ag are fine for solar. Or industrial. Industrial is fine for solar as well. Obviously, you don't
Most of
wanna
the
put it
time,
on
the zoning
residential.
regulations for solar don't exist yet. That's what we
Yeah, sometimes
run into
they
several
do, sometimes
places.
they don't.
Yep.
I was gonna pull up the Aurora plan set.
Yeah. So on every site, we have it fully engineered from top to bottom. And we'll go through and build this system as per the plan. Now, if there's some cases where, you know, we have to stray from the plan a little bit to make it work because of site situations, we'll go back in and do a revision to the plan set, you know, on the as-built drawings to make sure that the plan sets that you guys have, that you're keeping, you know, reflect what's actually there. But most of the time, it's very common that we would, you know, not much is going to change. Those sites are usually easy enough to tell if there's going to be a problem on the front side, so we don't typically have a lot of changes from the plan set. But it is nice for you guys to be able to have a plan that kind of shows exactly, you know, what's going on. This is Aurora, right?
Yep. Trying to get a good size here.
There you go.
Yeah, so this is the picture you saw that we have all the interconnection equipment in one spot. Here's where the transformer was. And then if you can just kind of slide it over a bit, you can kind of see the rows. And this is the difference in the blocks. One of the advantages of looking at Aurora, go up just a little bit so you can see this split between them. Yeah. So this particular site, we ended up having to do two separate blocks because of how it was orientated. So instead of having one big long skinny block, we actually have two motors on this site driving it here and here. So we have some options to do, you know, different things depending upon your site. If you have a site that's a little unique, if you even have a site, I was just going to say, if you even have a site that doesn't actually fit on the lot square, the roads next to it aren't running north and south, and so at Gothenburg, the roads next to it are actually running basically northwest and southeast, and so the field or the arrays on the field actually are crooked, so the drive lines are all in a manner like that. So we have the ability to fit the solar field to the lot, even if it's not perfectly square. We can definitely fit that in. Everything's already predetermined as far as how far we are away from these trees. We have a surveyor that comes out and actually pin places a flag where every single one of our piles go, so that there is no question, and we don't have to worry about our measuring being off or anything like that. We actually hire a surveyor to come out and pin place all those for us ahead of time.
Do you want to talk about the utility pole and the transformer?
Yeah, so on this particular site, it was a little bit unique because, go down just a little bit. Yeah, there we go. The transformer was right here on a pole, right here on a pole. And it was feeding the building, and there wasn't any power out here at all. And so what we ended up doing with NPPD, working together with them, and they're great to work with, by the way. We've had nothing but great experiences. But we ended up refeeding from this new transformer that we dug in the ground and provided all the conduits and everything for. We actually ran new wiring underground over to this building, up and over, across into where their feed was originally. We disconnected their power from the pole and had everything coming out of this one transformer. So even if your site is set up kind of like Aurora, where you don't have an underground transformer where we can just split off and do this, we have the ability to go ahead and do the whole works. And this is an upgrade for them too. This was really getting old and it really needed to be changed anyway. So it was actually a good time to do both of them together. But we're qualified to do not only the dirt work side of it, but we're, you know, master electricians, so we can do anything like that. So if there's a portion of the project that needs to be done and it kind of fits into the whole overall scheme, you know, we can just include it all together. And that's kind of what we did at Aurora. It was about an extra week worth of work to make all that underground happen, but that is something that we can definitely include in the project.
Do you know if on the plan set it shows what you did on the building?
Yeah, I think it does. I don't know if it shows very well. The pictures, do you have any pictures?
I don't know. Yeah, the AC side coming up and over the building ended up looking really cool too.
Yeah, we had 4 4-inch conduits that came up right here, went up about 10 feet, all the way across the building, down back into the ground. This is all concrete right here and with a big generator, and so we couldn't get to their existing meter can. So the only way to do it would be, and they had big water lines back here we couldn't cross. So we ended up on the building, over, back down to the ground, over, back up, and then into their meter. And so there's really not anything that we can't get done if it involves the electrical side of it.